Hello, Knox County. My name is Mrs. McMurray. I'm a fourth grade teacher at A.L. Lotz Elementary School. I am so excited to be with y'all today. I am a math demonstration classroom teacher, and we get to talk about fractions today, and I love fractions. So we'll jump on in. So we're going to focus in on two things. We're going to focus on two different standards. I took each of these texts from the instructional focus documents. Those basically look at our standards, what we have to learn in fourth grade, and they really explain what will it look like to be successful? What will it look like if I really understand this standard, what I have to learn? So this first one says we're going to generate equivalent fractions with denominators of 2, 3, 4, 5, 6, 8, 10, 12, and 100. Going back to that word generate, it just is a word that simply means make. We're going to make equivalent fractions. We'll review what those are in just a minute and really explain why the process that we'll use to find equivalent fractions, why does it work? And then the second focus for today, we're going to be comparing fractions. Is one bigger, smaller, or are they equal when we're comparing two fractions? I think sometimes the confusion that I see with students is when I say compare, how are they alike or different? That is what we're talking about, but more specifically in math, we're thinking about their value. We're comparing their value. Which one is bigger, which one's smaller, or are they equal? And again, that second piece of the standard is we're going to be able to select a justification for why two fractions are less than or greater than or equal to. And that, again, justification simply means, can you explain your thinking? Can you tell me why you picked this fraction is bigger than this one? So we'll jump on in with a quick review, and then we will look at our activities in your packet if you have those. So first things first, let's just talk about a fraction. A fraction is simply a number that names equal parts of a whole, or names a specific point on a number line. So I'm thinking about a whole split into a certain number of parts, and maybe I'm talking about one of those parts or all of those parts. So my example here, we have 1/4. Let me get my annotation back here. Great. We are talking about 1/4, the fraction. You can also call it 1/4. That would be kind of the standard way to write that fraction. In our model, that would look like I have 4 parts in the whole with 1 shaded in. On my number line, I have it marked from 0 to 1 with 4 spaces from 0 to 1 with my arrow pointing to that first spot. We could also think about it as, a group of anything. In this case, we have balloons. So it says what fraction of the balloons are red. Well, how many balloons are there in all? Well, 1, 2, 3, 4. There are 4 balloons in all, and only one of them is red. So that represents 1/4. So just a couple of quick reviews. A numerator, when I say numerator, I'm talking about the top part of my fraction, of that number above that fraction bar. It's talking about, this number specifically is talking about how many equal parts are being described. What are we talking about here? Are we talking about 2 out of the whole, 4 out of the whole, or whatever? In this case, my fraction is 2/6, which means I'm talking about 2 parts of the whole. So 2 parts out of the 6. On my number line again, because my denominator is 6, that means I have to have 6 spaces from 0 to 1 and my arrow pointing to that second one. So again, we call this the numerator, okay? We also have the denominator. Then the denominator will be below that fraction bar, this being the fraction bar. That number tells us specifically how many parts are there in the whole, because that makes a huge difference. It tells us how big these pieces really are. So in this case, we have the fraction 3/5, a 5 in my denominator. That means I have 5 parts in the whole. 1, 2, 3, 4, 5. I could also think about it on my number line. From 0 to 1, if my denominator is 5, That means I have to have 5 spaces from 0 to 1. Y'all are doing great. Thanks for hanging with me. All right, so now we are getting into the meat of what we're talking about today, and I am super excited. Equivalent fractions. So equivalent has a prefix. Can you find it? Equi, E-Q-U-I. That prefix, well, it sounds just like equal, doesn't it? So equivalent fractions are 2 or more, possibly 2 or more fractions that are talking about the same part of a whole, or the same point on a number line. So there are several ways to really find equivalent fractions. We're going to be talking about maybe using a model to show those equivalent fractions or a number line. You can also use multiplication and division, which I am super excited to talk about today. So the first thing that we're going to talk about is this fraction over here, 1/3. Notice I have 1 part shaded in out of 3 in all. So that right is showing 1/3. But what I want to do is I want to show how I could multiply to find an equivalent fraction. Now, this is really what I want you to listen into. You're going to multiply by a fraction that is equal to 1. So 2/2, something that has the same number in the numerator and denominator, that equals 1 whole. You have to make sure you're multiplying by a fraction equal to 1, because when I multiply anything times 1, you get that number. Nothing changes. If I say 100 times 1, that's still 100. I'm not changing the value. It's the same concept, the same idea when we're doing equivalent fractions. You have to multiply by a fraction equivalent to 1, like 2/2, so that I'm not changing the value of this fraction. So to multiply there, I would just multiply straight across. 1 times 2 will get me 2, and 3 times 2 would get me 6, which would give me the fraction 2/6. So what I'm showing there with multiplication is that 1/3 really is equivalent to 2/6. It would be very much like if I just drew a line right there, okay? To now show, I didn't change any of the shading. The shading is still there, but now what's represented in my model is 2 parts out of 6 in all, okay? You might also see it in some textbooks or workbooks or whatever. You might see something like this, and I wanted to show y'all so that you are familiar, but I really wanted to start out. You have to multiply something that's equivalent to 1, this fraction equivalent to 1, which is what you're doing here. You're multiplying by a fraction. When you see something like this, you don't just do the same to the top and bottom. That is what you do, but the understanding, the thought behind it is that you're multiplying by a fraction equal to 1, so you're not changing the value. So in this case here, I'm going to say 3 times 2, which would get me 6, and then 4 times 2 would get me 8. So this would also be an equivalent fraction. 3/4 is equal to 6/8. I'm not changing the value because I'm multiplying by that fraction equivalent to 1, just to get 6/8. Okay, you're doing great. Again, we could also say for 1/6, sometimes you'll be given that denominator of that second fraction to find your equivalent fraction. So you have to think, 6 times what could get me 36? Well, in this case, I know that 6 times 6 is 36. So if I'm multiplying that denominator, you really want to think, I'm multiplying by a fraction equivalent to 1. So it has to be times 6/6, which would get me then 6/36. So those are equivalent fractions. So you can absolutely multiply by a fraction equivalent to 1, but do you think you could divide by a fraction equivalent to 1? If I divide 9 divided by 1, do I still get 9? Absolutely. That's why I wanted to show you this one. You can divide as long as your numerator and denominator are divisible by the same number. So in this case, we might divide by 3/3. Still a fraction equal to 1 because my numerator and denominator are the same. So, and that's the same thing, I'm just dividing. So 3 divided by 3 would get me 1, and then 9 divided by 3 would get me 3. So again, equivalent fractions, not 3 over 9 is equivalent to 1 over 3. Y'all are doing great. All right, let's talk benchmark fractions here in just a minute. Let me clear. All right, we're ready. All right, so a benchmark fraction. I tell my kiddos a benchmark fraction is simply easy to picture in your mind. I bet when you were little, you understood the concept of half. If you had a friend or a brother or sister and you wanted to split something in half, you knew what that meant, right? And I bet more than once, maybe you fought over, is it really a half or did you get a little bit more? So benchmark fractions are ones that our minds are really familiar with, really easy for us to picture in our minds. 1/2 is definitely a benchmark fraction. When I say, could you split this model in half? Easy peasy, right? We also could think about 1/4. 1/4 is also pretty easy for us to picture in our mind, whatever whole that we're talking about. And then last but not least, 1/2 could be considered a benchmark fraction. Because as we transition into comparing fractions, we absolutely will talk about comparing fractions based on the benchmark fraction of 1/2. Great, y'all are doing awesome. So this would be the first activity in activity number 3, the first page. So we're talking about equivalent fractions, and we're really starting back with those models. So this says a model can show equivalent fractions. The model has 5 equal parts, 1, 2, 3, 4, 5. It shows 3/5. I know that because there are 3 shaded in of the 5 in all. It says to divide the model into 10 equal parts to show an equivalent fraction. Okay, well, I have 5 equal parts and I need 10. Well, I know I need twice as many equal parts. Well, look, you can just draw that line right down the middle, and each of those 1 parts is now 2 parts. So I have 10 parts in the whole and now 6 shaded in. I didn't change any of the amount that I have shaded in. I just cut it up into more pieces, still representing the same amount. So I'm showing those equivalent fractions there. That 3/5 is exactly equal to 6/10. 6/10. 3/5 and 6/10. Those are equal equivalent fractions. So that is in fact correct. Over here on your first problem, it says divide the model to show 1/2 is equal to 5/10. Now, it already has 5/10 shaded in, 1/2 or 5/10 shaded in for you. And all you have to do is add your tick marks, divide that to show 5/10. So some of the confusion sometimes that I see is, okay, well, I'm going to divide one side, 1, 2, 3, 4, 5. Okay, well, I have 5 parts now, so I'm good. That's 5/10, right? Well, are all your pieces equal? No, in a fraction, your pieces have to be equal parts. So you have to make sure that you're dividing those shapes equally, those shaded portions equally, meaning now I have 5 parts over here and 5 parts over here. So 5 shaded in out of 10 in all. Okay, y'all are doing great. All right, so we're going to transition from equivalent fractions into comparing fractions. We'll use equivalent fractions in this. We'll apply that skill now to really compare these fractions. So again, when we're comparing fractions, we're using the symbols less than, greater than, or equal to. I'm thinking about the value of these fractions and which is bigger, smaller, or are they equal? So we have several different strategies that we could use here and that we're going to talk about. You can find a common denominator, a common numerator, or use a benchmark fraction. So we're going to review each of those in this next little bit as we get started. So the first one that I want to talk about is finding that common denominator. Now, a common denominator, if you and I have something in common, that means we share it, it's alike, it's the same thing. So as I look at this first comparison here, 3 over 20 and 5 over 10, they don't have the same numerator already, and they don't have the same denominator already. But but I can make them have the same denominator by finding that equivalent fraction. That's really going to help us in our brain really make sense which one of these fractions is bigger. So we'll start with this first strategy. Okay, so I'm looking at my denominators and I have 20 and 10. Well, I know that I could multiply 10 times 2 to get 20, and then both of my denominators could be 20, which would make it nice and easy to compare. So what that would look like again, let me move this out of the way. I can multiply 5/10 times 2 over 2. Why does it have to be 2 over 2? Do you remember? This fraction has to be equal to 1 so that it does not change the value of your original fraction. So if I multiply 5/10 times 2 over 2, I'm going to get 10 over 20, right? Those are equivalent fractions, taking what we just reviewed and applying it now to comparing fractions. So what I'm saying here is this 5/10 is really equal to 10 over 20, and now I'm comparing 10 over 20 and 3 over 20. Well, that's nice and easy to know that 10 over 20 is in fact bigger than 3 over 20. If I'm talking about the same size pieces, 10 of them are going to be more than 3 of them, right? Great job. All right, our next one, we're going to be talking about, I'm going to change my color here so it's nice and easy for you to see. All right, highlight back over that. Cool. All right, so now what we're going to talk about is finding a common numerator. So sometimes my denominators, they're not super friendly with one another. 6 and 11 don't share a lot of common multiples. So I might look at my numerator to compare my fractions. Can I find a way to find an equivalent fraction to make my numerators the same, to make them a little easier to compare? Well, if I look at these, 5 and 10 are they're friendly, right? I can multiply 5 times 2 to get 10. They work well together. So if I say 5/6 times, can you think of the fraction we're going to multiply by? Times. You got it, 2 over 2. Again, keeping that equivalent to 1, so I don't change my value. I'm simply finding an equivalent fraction. I would get the equivalent fraction 10 over 12. So really, you can think about, I'm comparing 10 over 12 to 10 over 11, right? Now, as I think about this, what I like to do is think about how many parts am I away from being a whole? Well, here I'm only 1 part from being whole, and here I'm 2 parts away from being whole. This is closer to being a whole, so in that sense, it has to be greater, right? 10 over 11 is greater than 5 over 6. Really, the correct way to read this would be from left to right. So 5/6 is less than 10 over 11. Y'all are doing great. All right, my third one here, I created a comparison that I wanted to use a benchmark fraction. Now go back and think. A benchmark fraction is something that's very easy for you to picture in your mind. So 1/2 or 1 whole are kind of the main ones that we'll use and talk about. So 25 over 100, and then 60 over 80. Now, if I'm looking at common denominators, I'm like, oh, I don't know. They're pretty large denominators, not a lot of common multiples that we could find a common denominator. Even with my numerators, they're not working well together. I can't multiply 25 times something to get 60, or 60 divided by something to get 25. So in this case, it might be your best bet to use a benchmark fraction. So you want to think, I know they're both less than 1 whole. So I might think about 1/2. I'm wondering, 1/2, 25 over 100, is that greater than or less than 1/2? Well, I'm thinking about money. Are you thinking about money and pennies in a dollar? There are 100 pennies in a dollar. Half a dollar is 50 cents. So 25 over 100 has to be less than 1/2. What about 60 over 80? Well, 80 is super easy to think about. What's half of 80 or half of 8? Can you think? Half of 80 has to be 40. So 40 80ths would be 1/2. So 60 80ths have to be greater than 1/2. I can use that thinking that of a benchmark fraction to say, Because 60 over 80 is greater than 1/2 and 25 over 100 is less than 1/2, that means that 25 hundredths is less than 60 over 80. Y'all are doing great. We're almost done. Doing awesome. All right, so let's look at a couple of examples that you have in your activities in your packet. So up here, you'll see find a common numerator or denominator. That's the first part of comparison that we'll talk about. So there is a length of ribbon that's cut, and it's 3/4 foot. Okay, there's another length of ribbon that's 5/6 of a foot. Okay, so we're asked to compare the lengths using a symbol, those symbols being less than, greater than, or equal to. So I'm comparing 3/4 of a foot to 5/6 of a foot. Okay, now right now they don't have a common denominator, they don't have a common numerator, and they're both bigger than 1/2. So my thinking is we have to find a common denominator by finding that equivalent fraction. So what they did here, they said, okay, well, I could make both of my denominators into 12. 12 is a multiple of both 4 and 6. So it'd be nice and easy to multiply those fractions to get a denominator of 12. So what they did here, they're multiplying by 3 over 3 to get 9/12. And they're multiplying by 2 over 2 to get 10/12. So what we're saying is 3/4 is equal to 9/12. You can see that here. And 5/6 is equal to 10 over 12. I'm not changing the value. I'm finding that common denominator to make it nice and easy to compare. Because if I have 9 parts out of 12 and 10 parts out of 12, well, that's easy. I'm thinking that 10/12 is more shaded in than my 9/12. So 9/12 is less than 10/12. That's why I'm just comparing my numerators. How many parts am I talking about? Because my pieces are the same size, how many pieces am I talking about? And that would mean that 10/12 is in fact greater. So 3/4 is less than 5/6. Okay? I really like these true false, and my challenge to you guys is to think back to those instructional focus documents, and I want you to be able to explain why. Give me a justification. So we'll do a little bit of an example of what that would look like here. So I'm going to look at A. 2/3 is greater than 5/6 is what it says. Okay, instead of just going false, true, true, false, false, I'm really going to use my noodle. I'm going to think about my justification and try to explain what I know. Okay, so right now, my denominators are not the same, my numerators are not the same. So my thinking is I'm going to find a common denominator to compare these fractions because I know 6 is a multiple of 3, and that'd be nice and easy to make both of those denominators 6, right? I know that 2/3 is going to equal 4/6. Can you think about the fraction that you would have to multiply to get 4/6? Were you thinking 2 times 2 over 2? If you were, you're exactly right. Because that would leave me with 4/6. So all I'm thinking about, 4/6 is greater than 5/6. Even saying that out loud, it's like, no, it's not. If my pieces are the same size, well, 5 is going to be more than 4, right? Nice job. So I'm going to check false. Whoops, gave you the answer if you were looking. Okay, so looking at B, y'all, did you see that your numerators were already the same? That's one of your strategies to compare these fractions. So I have 4/10 and 4/5. Okay, now when your numerators are the same, you're going to think about that denominator. You're going to think about how many parts are there in the whole. Okay, so I'm thinking about the fraction 4 out of 10, 4 over 10. That means I only have 4 out of 10 parts in all, right? Or 4 out of 5 parts in all. Well, this 4/5 is closer to being a whole. It's only 1/5 away from being a whole. And really, as you think about the smaller the denominator, the bigger the pieces. So this is in fact true. Because 4/5 is greater than 4/10. If I have 4 parts out of 10, that's going to be smaller than if I have 4 parts out of just 5. okay? And then last but not least, we have 70 over 100 equals 7/10. Okay, so is there a way that I can make that denominator of 10 over 100? Well, that's easy. 10 times what is 100? 10 times 10 is 100. So if I multiplied 10 times 10 to get 100 and 7 times 10, what's 7 times 10? 70, easy peasy. Those are in fact equal because I could multiply by 10 over 10 to find that equivalent fraction. They are equal. Y'all are doing great. Last one, we're almost done. Okay, so we're going to talk again about those benchmark fractions. So Carol compared 3/4 and 2 over 1. 2 over 1, does that look weird? Why does it look weird? Because your numerator is larger than your denominator. Well, do you remember what kind of fraction that is? It's an improper fraction where the value is greater than 1, right? Okay, well, think about Carol's explanation, her justification. She says that 3/4 is greater than 2 over 1 because the numerator and denominator in 3/4, they're both greater than 2 and 1. She's saying, well, 3 and 4 are bigger than 2 and 1, so 3/4 has to be bigger. The justification there isn't correct, right? I can't just pick the numbers and say, oh, those are bigger numbers, so it has to be bigger. You have to think about what part of the whole is it really talking about. So we're going to compare both of these fractions to the benchmark fraction of 1 whole. Well, I gave it away a little bit earlier, but 2 over 1 is greater than 1 whole, right? It's really 2 over 1 is equal to 2, right? Because I have 2 parts with 1 part in the whole, and I have 2 of those, so 2 wholes. So I know that 2 over 1 is that improper fraction. It's greater than 1, and 3/4 is definitely less than 1 whole. I love this number line here. We have 0, 1, and 2. You can see that here. 2 over 1 is really equal to 2. And then 3/4 is under that 1 whole benchmark fraction. So Carol is not correct. You can't just pick those random numbers and say, oh, those are bigger. You have to think about what do these numbers represent as a fraction. All right, last thing, I love this one too. Really thinking about that justification, that explanation. So we're gonna think true or false. Now I don't wanna just check, and look, it looks true. I really want you to challenge yourself to think about what benchmark fraction could I use to compare these fractions. So 9/8 is greater than 11 over 12. 9/8, did you notice? Your numerator is bigger than your denominator. Do you remember what that means? That means it has to be greater than 1. So this is greater than 1 whole, and 11/12. Is that greater than 1 whole? No, so true. That is in fact correct. We can use the benchmark fraction of 1 whole to compare. All right, 2/5 and 5/6. Now I can't use the benchmark fraction of 1 whole because they're both less than 1 whole, so I have to think about 1/2. Now, if I think about 5/6, well, what over 6 would equal 1/2? What's half of 6? 3, right? So 3/6 would be 1/2. So this has to be greater than 1/2. And 2/5, well, that has to be less than 1/2. And really thinking about half of 5 is a little tricky, but I bet you can do it. So using that benchmark of 1/2, I know that 5/6 is greater because it's greater than 1/2, and this is less than 1/2. Last but certainly not least, we'll talk about this one. 7/10 and 2/4. Well, 2/4, I hope it jumped right out at you. What does that equal? Does it equal 1/2? What does? This equals 1/2, and 7/10 is it greater than or less than 1/2? 7/10 is greater than 1/2. So that has to be false. If we flip that inequality sign, that would have been correct. We could have used our thinking of our benchmark fraction 1/2. I'll save these last 2 for you to do. And that really wraps it up for us today, guys. I saw this family circle cartoon, and it made me think it was perfect for our lesson. So the sister is saying, wait a minute, why'd PJ get 4 sandwiches that I only got 2? Why is that funny? Is it the same sandwich slices of bread? Of course. They're just cut into equal parts. So 4 parts is 2. Is it really more? No, it's not really more, but equivalent fractions. Cool. Y'all worked so hard today. I'm so proud of you. I hope you had a fun time talking about equivalent fractions and comparing fractions. Y'all did great. I hope you have a fabulous day. Bye.